So here's a recap, the workflow for post-processing a single GNSS observed point in TBC. This is TBC 5.9. Process will be the same in pretty much any of the recent versions over the past few years. Begin by making a new project. I do have a template already set up, but I'm going to go for metric so I can put in the settings afresh. There's a blank template really with not much of a coordinate system set. The first thing I'll do then is just go into project settings and configure a few things, starting with the coordinate system, which I will change to OSTN 15 for this data set. Really, for GNSS processing, there isn't too much, if anything, that needs to change from the default settings. I might just change the default standard errors in anticipation of the network adjustment. Put in a millimeter for centering error, and I generally put in 2 mil for height measurement error. Okay, that should all be fine in terms of project settings for GNSS processing. I'm going to go next to bring in the raw data files. This happens to be a T04 file. T04 files support the, I suppose, more recent satellite constellations that have come on stream. They're being more widely used now in the post-processing, the Galileo and the Beidou. I'll drag and drop that into the project and check my antenna information. Okay, I've got a observation date on the 16th, 5 hours of data, starting at about 5 in the morning. That's British summertime still. The antenna information is the critical element, so it's a Zephyr Model 2 in this case for our base setup here in Liverpool, and we tend to use bottom of antenna mount 0 as our height reference, as it's on a fixed bracket attached to the side of the building. Antenna models should be set to automatic. TBC will use the best antenna model for the receiver or the antenna used that it has in its library. So I hit OK. The dates come in. Now I'm not going to use the VRS download through TBC or even set up OS Direct download in TBC, which is another option. What I'll do is I'll go the conventional route and go onto the Ordnance Survey website to grab some data for this location. As I've split the screen here just so I can see both interfaces side by side, got the OSNet website up, OSNet Rhinex data is the address. Got my properties dialog open in TBC so I can see what is currently an autonomous coordinate for the base position, the observed position. We only need an approximate search location in the search location box, but I'll just copy and paste that across with the space in between the easting and northing. Give a station search or radius search. I prefer, if possible, to use 5 stations in the processing if there's enough time in the observation to do that. So 5 hours really should give good precision processing up to about 60 kilometers. So I'm going to put 60k in the box there, radius search, and it was on the 16th. It was 5 in the morning, British summertime, which would be for GMT. It's on GMT. So it would finish at 9, but I'll just put 10 to give a bit of extra wriggle room there, and hit display. So within 60k, it's only picked up 4 stations. It's on the coast, so that is often the case with data on the coast. So I'll go with these. So it's going to download a zip file once the processing is complete on the Ordnance Survey side. The data's downloaded, and I just opted to save it in this folder here, and I'm going to extract it now. Here's the things you'll notice with Ordnance Survey supplied Rhinex data currently is that information is provided per core station. This will be St Asaph here, but it's supplied in 2 formats. You've got the older Rhinex format here, which will be version 2, and the newer Rhinex format here, which supports the whole range of modern GNSS constellations. Depending on the version of TBC that you have, if you have a very old version, perhaps you'd bring in the older format. But anything relatively recent, you should be able to bring in the newer Rhinex format. So I'm just going to go through and delete the older files. It's possible to see as well that the data's separated into 1-hour segments, which again is something that will be new to you if you've not processed Rhinex data from the OS site for a while. Shouldn't make any difference to the processing within TBC. I'm just going to select all of those files and drag them across into TBC, and the antenna check-in will open as it did with the observed raw data in a moment as well. Okay, so there's the first file for St Asaph starting at 5 AM and going through. The antenna types, these are the more critical factors, so they're all known or identified, which is the key thing. And then the receivers, not so significant for the processing, but just out of interest, you can see which type of receiver was installed or was operating at each station. Okay, so my raw data in, got my OS Rhinex data I'm going to process against using the fixed OS stations as reference to adjust relative to. Optionally, it's possible to bring in precise ephemeris, which has got more precise locations for the GNSS satellites on their orbits. That's obtained through the survey ribbon on Internet Download. Now, these addresses have changed a lot over the past year or so, and with an older version, some of these links might not work now. Again, depending on when the data was observed, will determine which product it's possible to import. I'll try the MGEX final orbits, which is multi-GNSS, that covers all constellations. Okay, so the final orbital product isn't available yet, so I'll go for the rapid one, which is typically available 3 days after date of observation. So this one is available, and I'll import it to the project. That's finished importing, and close this dialog. You can see I've got Project Explorer open on the left. See the imported raw data file here. I can see the Rhinex files that were sourced from the Ordnance Survey, and I can see two SP3 files here, which are the precise ephemeris data with the more precise GNSS orbital positions in them. We're going to need to process the baselines and evaluate how good they are from their processing statistics. There is an optional check that can be performed on the coordinates of the Ordnance Survey stations and the quality of observed data. It's called a coordinate recovery check. I'm going to run through it, but it is an optional sort of pre-processing check on the data. I prefer to do it myself. Depends how pressed you are for time on this one. So I'm going to pick the nearest station in Project Explorer to the observed position, and I'm going to pick one of the input coordinates that have come from the Rhinex data, and only for one of these. You don't need to set it for multiple, just one. The way TBC works, it will use the highest quality value for any input data for a particular point. What I'm doing here then is just changing the quality to control for one of those input coordinates for that point, and that will then be used as a reference for that point in general. So I've changed the status, so now I've got a red recomputable to tap. I'm going to select the baselines to process, which will just be the ones that are connected to the observed point. And back on the survey ribbon, I'm going to hit the Process Baselines button. When the process is complete, check in the results columns. It will definitely see a fixed solution. Anything other than fixed shouldn't be used in the project to compute any final coordinates. Horizontal precision, again, the values here are going to be determined by how much data was observed versus the distance between the GNSS receivers in question. In this case, a point at Daresbury here and the observed position. So the more the data, or the shorter the baseline, the better the processing precision generally is. Horizontally, anywhere up to and about 10 mil is normal. Vertically, anywhere, again, between 5 and 15 mil, sometimes a little bit higher. Again, it depends on the positioning of the receivers and the distance. RMS is often anywhere between sort of 10, 12 mil and 30, well, not specifically millimeters, but it gives you an idea of the noise in the solution. So on the face of it, everything here is fine to continue, so press save. And at this point in time, the baselines have been processed into vectors. So I have a vector here coming in from Daresbury into the observed position. That's providing a coordinate now for the observed point, a modified coordinate. And from there, vectors are radiating outwards back to the OS stations. So it's possible to do a check on how well these vectors that radiate outwards fit against the coordinates initially supplied by the Ordnance Survey in the Rhinex files. That's what the coordinate recovery check is. So it's possible to select the stations that have been processed outwards to, so that would be, in this case, Blackpool, Manchester and St Asaph. A right click and then the point derivation report is selected to perform the comparison. First station that pops up in the list is St. Asaph. So it's taken the coordinate resulting from the vector coming from the observed position to St. Asaph as a reference, and it's then compared the coordinate from the Rhinex file supplied by the OS to it. So broadly we're looking for a tie-in within 50 mil, but of course the tighter the tie-in the better. It's got 5 mil in easting, 3 mil in northing, and about 12 mil in elevation. Blackpool 5 mil, 8 mil, and 16 mil. And Manchester 6, 4, and 10. So again, very typical of what you'd expect to see in this report. Anything above 50 mil or getting up towards 50 mil is a bit of a warning flag that the data may not be so good, or there may be some small issue with the coordinate. And close the report. Personally, I like to clear the processing now, although it's not mandatory, and I like to start again with my additional stations fixed. Just keep it simple. So I'm going to clear the processing. And the next stage then is to fix or give control quality prior to the network adjustment of the, in my case, 3 remaining OS stations that weren't fixed before. So I've selected those. You have to make sure that you're selecting the Rhinex file entry and not by clicking on the name of the point. Then it's possible to change each to control quality and recompute by hitting the red recompute ball. Select the input data again and repeat the baseline processing. The statistics are going to be exactly the same as previously. I'm just doing it this way so that I know what I've got fixed, which way the vectors are going. There's no ambiguity about it. And we can see here in the process baseline summary that the vectors are originating from the OS stations and they're all converging on the observed position. It is possible to open a more detailed report, both now and subsequently in TBC. If one's required for QC records, you can select multiple baselines here or just one, as I've done, and tap the report button. You can see the more detailed report here. So the ephemeris used, the maximum PDOP during the occupation. Again, you've got the precision values here and the estimated noise. Satellites that have been used in the processing, so GGPS, R GLONASS, E Galileo, and C Beidou. And then you can see the noise variability in the processing per satellite. TBC is very smart at utilizing the best information from the data provided. So there shouldn't be any need to tinker or adjust really any of the input data or the time periods, unless there's a very clear reason to. For example, if you knew that the I don't know, if a tripod was disturbed and it was reset after 30 minutes, but the processing or the data storage wasn't paused and restarted, then you could cut the first 30 minutes out of the data, something like that. So I'll hit save. Everything's fine so far, except that there are now 4 vectors converging on this point, and currently this point will be deriving a coordinate from one of them, but it's not going to be using the, if you like, mean adjusted position from all 4. So the network adjustment is going to come next, which is still on the survey ribbon, adjust network. Because this isn't a network of observed points, it's just a single point. So there isn't really a network between points here. It's a bit of a radial survey. Then this isn't a two-stage network adjustment process. We can go straight to a fully constrained situation where all the control is fixed, the OS stations. There's a button up here which will just tick all the boxes for you. So they're being fixed in 2D and in ellipsoidal height as well. Press adjust. So the reference factors come out at 1.43. So the reference factor being above 1 indicates that based on the input information, the station setup precision estimates, and the amount of data found in the processing versus the estimated amount of error in the data. Because it's come out greater than 1, it's found more error in the processing than it was anticipating. 1.43 isn't a terribly bad result though by any means. Generally anything less than 2 may well be okay. It might be just a case of looking at the weightings, especially if you're confident you've got enough data to deliver a good result and the receiver was placed in a good location. I'm going to take a look at the baseline, well, not the baseline, the network adjustment report, and just check there's no outliers. Outliers are vectors that don't fit satisfactorily well within the network of observations. So you can see the adjusted coordinated positions, both in grid values and latitude, longitude, summary of which stations were fixed in the network. So we've got error estimates here on the adjusted position, and the process vectors. Each vector's got a unique reference that's been used in the adjustment. Standardized residuals here that will be tested against a tau criterion. Any that exceed that tau criterion, that would be identified as an outlier, but none are flagged in red, so there's no outliers in this data set. So there's no observations sitting outside the computed tau criterion of 2.2. Two methods of going from here. You could go back into the project settings and perhaps adjust the centering error. However, first thing to try within the network adjustment is to scale down, or in this case scale up, the amount of anticipated error for a rerun at the adjustment. So it's going to scale up the amount of anticipated error by a factor of 1.43, and that should then match with the computed error, and when they match, the network reference factor should come out closer to 1, and it will apply the chi-square test to check that the network still fits together at that level. So just adjust, check the results. Yes, it's passed now. You can look at the network adjustment report in case that needs to be printed off for a QC record. You can see the amount of estimated error in the easting, the northing, and the elevation, and that will be the same information as if the point was clicked on or it was selected in Project Explorer. You get a little summary here of that error estimates as well. So that will give us our finished final adjusted coordinate for the observed point. You can see those values here. If they're to be transferred out of TBC, of course they could be exported in grid. If they're going to be exported in latitude, longitude, perhaps to import an RTK survey onto or to place into another TBC project with some other GNSS data. Just be careful that in project settings, in units, the lat-long precision is set to 9 decimal places before you export. So that's only if you're exporting in latitude, longitude, decimal degrees. Obviously that doesn't apply if you're exporting in grid values. Just to finish, a couple of quick things. If you want to just quickly copy and paste coordinate out TBC, pretty convenient just to open the point spreadsheet. You can highlight the rows, clicking down this left margin for any coordinates you want to take out, and then if it's just this one, just to right click and then copy, and then that will just paste. As to any text paste into Excel, Word, Notepad, etc. And of course, if you have an internet connection, it's also possible to turn on some background mapping or satellite imagery as well, using the button placed towards the bottom center of the toolbar at the base of the screen. And that concludes this video, just a recap on the process of bringing raw data, GNSS data, into TBC for post-processing, grabbing the RINEX data for Ordnance Survey base stations, bringing those into the project, processing the baselines, and performing the network adjustment on the derived vectors to get an adjusted coordinate for the observed position.